Last week, my lab partner and I conducted a mini-lab on the separation of mixtures. We recorded the masses of iron filings, sand, and salt. Then we mixed them together to form a mixture. After, we used separation techniques we learned about to separate the mixture and record the final masses of the sample of iron filings, sand, and salt. Using the original masses as the true values and the final masses as the experimental values, we determined the percent errors. Regarding the masses of the iron filings, there was a 2.14% error. There was a 47.12% error in the masses of the sand. In the masses of the salt, there was a percent error. There were sources of inherent error that led to this percent error in the masses. When we filtered the sand through the filter paper, it was wet from the water we had placed in it. This caused some of the sand to stick to the filter paper and made it impossible to remove all of the sand from the filter paper. To minimize this error, we could have recorded the mass of the filter paper without sand, then measured it again with the sand stuck to it. By subtracting the mass of the paper without sand from the mass of the paper with sand, we could determine the mass of the sand and eliminate the need to transfer the sand off of the filter paper. Separating the sand wasn't the only part of the lab that contained sources of inherent error. The water used for the salt water was not distilled. That means that when we evaporated the salt water, outside substances that were previously in the water could have skewed the purity of the salt. To remove this source of error, we could have used distilled water. Also, when evaporating the salt water, some salt may have popped out of the evaporating dish because it was being heated up to intense temperatures. This salt was lost to the environment, and the mass could not be recorded with the rest of the salt. Making sure that the watch glass is the correct size and placed on the evaporating dish properly would minimize this error and help to prevent the salt from falling out of the evaporating dish. Utilizing all of those strategies would help prevent sources of inherent error and would reduce the percent errors in this lab.